What are the forces present in this question? Obviously, there's contact between block B and C, so B is pushing C rightward and C is pushing B leftward, and we label the forces as FBC and FCB respectively. Likewise, there's contact between block A and block B. So block A is pushing B rightward with a force FAB, and block B is pushing A leftward with a force FBA. These two pairs of forces are of course action and reaction pairs, and so their magnitude are exactly the same, just that they are directed in opposite directions. Now to answer part A. If we consider ABC as one single mass, then these two pairs of contact forces will only be internal forces. They will cancel each other out. So the only external forces acting on ABC as a single mass will be the rightward 18 newtons and the leftward 6 newton. So it's pretty obvious that the net force acting on ABC as a mass is rightward, which means all three blocks are going to accelerate towards the right. Now, if you think about block B as one single mass, then the only external forces acting on block B would be FAB and FCB. Since we already know that block B is going to accelerate rightward, that tells us that block A must be pushing B rightward harder than block C is pushing block B leftward. And that's how we are going to answer part A. Moving on to part B, first we'll consider ABC as one single mass. So again, the contact forces will be internal forces, which will cancel each other out. So the external forces acting on ABC is just the rightward 18 newtons and the leftward 6 newton. Since we know the acceleration is towards the right, we are going to take the rightward 18 minus the leftward 6, and we equate it to the mass of ABC, which is 14 kilograms, times its acceleration A. From here, we calculate that the acceleration is 0.857 meter per second square. We are now going to apply Newton's second law on block C alone as a single mass. So if taken as a single mass, block C experiences two external forces. That's the rightward push by B and the leftward force of 6 newton. Again, since the acceleration is rightward, we are going to take the rightward FBC minus the leftward 6 newton, and we are going to equate it to block C's mass times block C's acceleration. From here we figure out that block B is pushing block C with a force of 8.57 newton. It's easy, isn't it? So to apply Newton's second law, it's really quite easy. First, you have to choose your mass. After you have chosen your mass, you just sum up all the forces acting on that mass, and you equate it to that mass multiplied by that mass acceleration. Easy. And thank you for using XM Physics.